Hi, everybody. Thanks for joining. I'm Alastair. I'm a community technologist at Percona, a long-term database nerd, and Postgres guy. My big interest beyond the specific technologies is in how open source projects can work with each other, what they can learn from each other. What I'm going to be talking about today is this exciting new world of building natural language and agentic apps around Postgres, and what we may be able to learn from how other applications, particularly around databases, have been built in the past, and where maybe we need to be a little bit careful about transferring the lessons a little too literally. So we start off with the idea of sending the workload to the data. And this idea really sort of saw its peak in the massively parallel databases behind BI and analytics systems and in the big data infrastructures. And the goal here really was to be able to keep the data in the rawest, richest possible form. And then using the massive bandwidth available between disks and processors, potentially engineered systems where there were multiple servers and there was significant network bandwidth between them. Crunch all of that down to produce a small answer to send back to the end user over what, even still in a corporate environment, was a rather smaller network. This worked very well for big aggregated reports. It also worked very well for statistical modeling. Once the process of building something like a linear regression model could be pushed down into one of these scale-out databases, there were multiple orders of magnitude in the improvement in the performance of those processes. Even bulk scoring, there were sort of 30x, 40x gains by being able to send that little model down to the database to work on all that data. Now, the analogy feels quite different for the agentic world, because we're not talking about moving this data with massive hundreds of tons of the stuff over ever narrower bridges or ever weaker bridges. We're talking about the air freight cost of putting something on a plane to the other side of the world, because the LLMs are almost certainly not in the same machine the database is in. And we want to have quite a small result to send to them anyway, because if we're using hosted services, you pay for every token that goes. Or if you are hosting your own, there are restrictions on quite how big a context window you can use, and then that gets worse as you take concurrency. So keeping the final answer small, which is what a good SQL query should do, and what a lot of the developments in the SQL standard have been trying to let us do better, is really what needs to be achieved here, rather than trying to get the thing that's going to be talking to an external LLM anyway down closer to the big raw data. So another standard rule of thumb for these big MPP systems was that for a lot of things that would normally have been indexed in transactional environments, the goal was just to scan faster, because the normal trade-off around an index, which is that it costs more computationally, potentially in I/O, at write time, and then saves at read time, doesn't hold as well when there are tens of thousands, hundreds of thousands of items behind each entry in the index, and you're not just trying to jump directly towards one or two. Now, some of the lesson here may also apply to small sets of embeddings. In order to get the benefits of PG vector, the understanding of vector types, the comparison of their distances, you don't need an index. And the impact of keeping those indexes up to date may be quite high in environments where there is quite a lot of churn, or for items, some items of recent work history, for instance, that may only be read once or twice, or may never be read. The overhead of managing the index may not be worth it. You can scan, depending on quite what level of performance you're looking for, 5,000, 10,000 embeddings, and compare them to a target embedding in an acceptable period of time. You can also, if you have other filter criteria going on at the same time, apply those criteria to shrink the list. It is also worth noting here that if you do this, you will get a full nearest neighbors comparison. The approximate nature of those retrievals is not a result of the vector distance comparisons. It is a result of the index optimizations. So if you're willing to pay a little bit on a small list for complete recall, the option is open to you, and shrinking the list has various other impacts, which we can look into a few more of. The first question around filtering lists beyond the result of vector search is that PG vector by default will return a limited set of approximate nearest neighbors from the index searches, and then those results will be filtered by any other criteria you've put in. So if we have a look at our little group here, we have our 7 little dots. If we only want to return the blue ones, we're only going to get 3 results. So this results in oversampling, so more distance comparisons than may necessarily be required, and then filtering down afterwards, you may still end up with not enough visible results. As of PG vector 08, there is now an iterative search model which you can activate, which keeps going until the target number of filtered rows has been reached. But still, there needs to be a distance calculation on every item, and the structure of the index is still determined by all the items in the index. So if we're talking about one of the inverted flat indexes, the centroids for each of the lists will be done by the entire group of members. For instance, on our little illustration here, we'd end up with quite a few centroids down there on the bottom right. But if we were only looking at the green ones, the centroid may shift up and left a little bit. So if we go back to what the big databases did to try to just be able to scan faster, one of the big things was partitioning. So instead of going through every record and checking that it matched whatever the filter criteria were, you know that every red item is in a particular partition. You know maybe that every snippet indexed yesterday is in a particular partition. Now, if this gets the volume down far enough, great. If it doesn't, there is still upside to this, because partition tables in Postgres will have partitioned indexes. So the vector index on that partition for those particular criteria, let's say yesterday's newly added snippets, will be smaller. It will be shaped correctly for the data, so it'll have its centers in the right place. If you're talking about the flat index, it'll have fewer layers in because it is smaller. We're talking about a hierarchical navigation index. And this effectively allows you to search by the additional criteria first before doing the vector similarity, which is a considerably more computationally expensive exercise and will give you better recall because you have the shape of the index right and you're not scanning, you're not doing a whole bunch of additional comparisons first. The other question when we go looking for data is, of course, what we're allowed to see. If we look at the big business intelligence applications, which used to sit atop the data warehouse engines, they generally had single application service accounts. They managed access. And in that world, as analytics democratized, as we saw more and more people connecting up their Jupyter notebooks, their various vertically specialized analytical tools, the whole question of who had access to what fragmented, and the authorization got pushed down to the lowest common layer, which is the database, or in some cases, some proxies over that, things like Secupy and Baffle, but that's a very specialized set of solutions. With this went the central management of authentication, so that at minimum accounts could be turned off in one place, and everything that a particular user had access to, they would then lose access to. There is a complication here which is quite pronounced for Postgres, which is that a user must exist as a role in the database before authentication can even be attempted. So running access to Postgres and Postgres derivatives based on authentication services like Active Directory requires synchronization work to ensure that the users exist as roles in the database and that the relevant group permissions to associate them with the relevant access has been transferred. So while this goal of every user has their own access, who accessed everything is visible in the database's audit log, is a great sounding goal to chase. It does come with more operational overhead, and as we see more and more agentic workloads looking at more and more sort of general operational databases, which tend to outnumber the analytical ones, this is an area that's going to have to see quite a lot more work. Postgres 18 introduced an OAuth bearer model, which begins to start taking some of those things apart, for actually communicating authorization rather than just identity. But those integrations are currently still quite incomplete. The most interesting thing that's been done with it is that OpenID Connect authentication has been built on top of it as a plugin. So OAuth or mutual TLS are really the things that look like the option at the moment for authenticating as individual users to database backends. How the authentication is done also shapes how some of the networking is done. So if we are, for instance, looking at automating PSQL as the way for our agent to communicate with Postgres, and all the agents understand PSQL quite well, it does come with the downside that those connections are very short-lived. This is a problem we haven't seen for a lot of Postgres application backends in a very long time. We may build poolers to ensure that they don't get overwhelmed, specify a maximum number of connections. We may build poolers on the application side for some performance management issues, but actually avoiding that overhead that comes with connections being created, kept alive for a single query, and then dying is something that hasn't happened in the application world for a while, but is now starting to happen again with the process of automating PSQL calls. If you're instead using an MCP server, they generally have their own connection pools. And it's fairly easy to see whether you are experiencing this connection churn, because on a client, you'll see that whatever Postgres connection you catch open at the time is coming from a higher and higher source port number. If you look at the back end, you'll see the live PIDs growing, even once the other briefly lived connections have disappeared. Now, whether you're using PSQL, whether you have an MCP server that may not be quite doing what it's supposed to on connection pooling, the first option to reach for is pgBouncer. Very simple, easily configured connection pooler. And if you're deploying either your MCP server or PSQL as sort of baked in part of your application, baked in part of your agent, you may then give them a client certificate to do the relevant authentication with. There are flows also you may be able to follow to get the agent to get relevant OIDC credentials to use with PSQL. But there is currently no OIDC support in pgBouncer, and there is no OIDC support in any of the Postgres MCP servers, even though OIDC is supposed to be the preferred way of dealing with authentication in MCP. So really, for authentication here, it's probably certificates. We don't really want to be automating password work here. And therefore, if you want to use something specific to the agent, it'll have to be baked in as part of the agent's environment for pgBouncer or the MCP server to use it. We spoke back on the first slide about the need to write a good query to get the right and the minimum data back to then be able to send off for further work. And this is just an area that gets a lot of attention on its own around the use of databases like Postgres with generative AI, the idea of generating queries. And it's an exercise really in taking the meaning of a question and matching that to the meaning of the data. The first barrier here is that the meaning of the data is a little complicated a lot of the time. It's not just the field names. They will be concatenated and abbreviated and compacted in all sorts of ways, which may very much be specific to the organization. Some of the field names may also no longer really represent what's in them. The broader meaning above that, how some of them are supposed to be authenticated, what some of the organization's definitions of things are, for instance, what constitutes an active customer, also needs to be documented in some kind of way. So we're back in the world of the semantic layers for BI and analytics, the business objects universes back in the deep past, and the attempts to do automated query generation have made that very old thing very new again. One of the upsides of this for query generation, an upside of having some structured, succinct definitions of the meanings of the data, is that it's probably a smaller context for the process of building a query than just scraping what's what's in the database or what other people have queried. So that comes with potentially some cost savings on services. It comes with some capacity savings on self-hosted things, but it also means that there is less opportunity for hallucinating and going off track. The LLM can't decide to include data from a table it's never been told about in the definition. This is also an area where questions around hybrid retrieval become quite important, because words that may, in general English usage, be effectively synonyms may have been adopted for different meanings inside an organization, and therefore have certain specific implications for how queries are built. So the retrieval for this metadata may not just be semantic. There may be a need for a keyword layer over the top of it to make sure that the specifics of how the organization uses language are respected. So the story is always just to use Postgres, right? You know, we can do anything we really want to behind these agentic applications with it, except there are some things that are a little rough on a Postgres database. Yeah, very, very high churn activities. Yeah, things like the current goal of agentic runs, feedback from some of the tools are written fast, not needed for very long. So if the application complexity, if the sort of available tooling suits it, there may be better backends for that, something like Valkey. But also, there are ways to make doing that stuff in Postgres kinder to the database. And we can ensure that we don't thrash our Postgres instance with these activities. The classic statement here is don't put a queue in a database. And it's something everyone's heard. It's probably something almost everyone has said. But there are still a lot of people who really want to. And at least some of the reasons that people want to actually don't sound that crazy. You know, there are some queues that just don't need all of that performance, all of that optimization that a dedicated queuing engine will provide. You know, a minimum production grade setup of RabbitMQ will move tens of thousands of messages a second. If all you need is a few hundred a day, well, is it really worth the other component? There are also people who want to keep the transactional boundaries around what goes into those queues the same as the transactional boundaries around other stuff that happens in the database. So this has been tried. It's been tried in a lot of ways. It's known to be something generally that results in bloat, that results in things getting stuck once there's one old transaction and the performance falls through the floor. Now, there is an implementation that avoids a lot of those problems. And it's interesting, not just because it can do queuing without completely thrashing the database, but also because some of the ideas behind it are available for doing other short-lived, high-churn work in the Postgres environment. So the project is called PGQ. Look very carefully at that spelling if you go searching for it, because any other way you want to spell with underscores or the full word Q or just the letter, etc., you will find a project. PGQ is a re-implementation in PLSQL of a C project that was built at Skype 20 years ago, called PGQ, just 3 letters. And the innovation in this tool is that it uses the transaction visibility mechanisms in Postgres to identify what tasks still need to be done and which have already been dealt with. So this avoids the process of marking items as in progress or completed in a long work queue. So there's no update in that hot path. There's no bloat in that hot path. So this is interesting just as a project on its own. If one of the things your agents need to do is cooperate through some kind of work stream pattern, but because it is built in PLPGSQL, because all of the functions that are used are available in queries, the option is available there to learn from it for other workloads. So you can go back and find the the current state of tool outputs from a recent batch without having to go and mark all of them as having been used, etc. There is also a pattern that PGQ uses for rotating its task tables, which could be used for rotating those sorts of scratch tables for other data, so that there are not long-lived tables and their long-lived bloated indexes to deal with for cleanup after the fact. Thank you very much. And please, even if you cannot keep a human in the loop, keep a human in the source.